Welcome to part 3 of the day 1 learning about interfaces, classes, and objects using the Randomizer project. So today we're going to quickly review the Randomizer interface and then the coin class, and then we're going to create some code to actually use or create a coin object to see how objects work. So, just as a quick review, recall that a randomizer is any object that could be used in a game context to introduce the idea of randomness. And we've distilled a randomizer down to the following methods or attributes. All randomizers should be able to tell us how many possible outcomes they can generate. They should be able to give us their current value in the form of a number. In the case of a coin, this might be 0 for tails and 1 for heads. In the case of a die, it would be the actual face value of the die, 1 through 6 on a standard die. In the case of cards, it might be the index of the card within an array. For example, it might just be a number 0 to 51. Now, in the case of get current face, what we're saying is that we want to also be able to get the value currently showing on the randomizer in the form of a string, so that for a coin it tells us heads or tails. For a die, it would just show us the number, but represented as a string value. And then on a deck of cards, we might actually see the value of the card, such as 4 of diamonds, 2 of clubs, king of spades, etc. And then finally, we have one method that is different than the other methods we've just talked about so far. These all get information about our randomizer. We have one method that allows us to make our randomizer actually do its job and randomize itself. In the case of a coin, this would mean flipping it. A die, we'd be rolling it. A spinner, we might be spinning. And a card, we might be drawing a card from the deck, or possibly shuffling the deck and then drawing a card. Okay, so let's look at our first randomizer object. Now, we created a class, and remember, a class is a blueprint for an object. It is not an object itself. The class are the instructions for how the object will work. But until we actually create an object from the class, we don't have an object yet. Now, what we've said about a coin is that it implements, and that's the Java keyword, implements the randomizer interface that we created. Classes may have instance variables. An instance variable is a variable that has a scope that is the entire class itself. That means that the variable could be used in all of the methods within the class. Next, we have a constructor, and a constructor that doesn't have any arguments is often referred to as a default constructor. All objects have a default constructor. If you don't create one, Java actually creates one for you. Now, what should a constructor do? Well, a constructor's job is to initialize an object and get it ready to be used. So in the case of a coin, what does that mean? Well, we declared this variable heads, this instance variable, but notice we didn't give it a value. One of the jobs of a constructor is to give all of our instance variables appropriate values. In the case of a coin, we do that by actually calling a method that exists within the class, the randomize method. And the randomize method takes a random number between 0 and 0.99999 and determines if that number is less than 0.5, which it should be exactly half the time, and says when it is, then our coin is heads up. If it's false, then our coin can be said to be tails up. So we call the randomize method within our coin constructor because the very first thing we want to do when we have a new coin is say that coin should start off with a random value, either heads or tails. Now, next, what we do is we need to look at each of the methods that was listed in our interface. Each of those methods, because we've implemented that interface, must be represented within our class. So our first method is get possible outcomes. And in the case of a coin, there's only two possible outcomes, so we return heads or we return tails. Then we can get the current value of the coin. And if it's heads, we say that it has a value of 1. If it's tails, we have a value of 0. And then, of course, we get the current face of the coin. And if it's heads is showing, then we return the value heads, which is, of course, a string. If it's not heads, it must be tails. And then we've already discussed what the randomize method does. Okay, so one last point to make here. Why do I just have randomize here and not something like coin.randomize or anything else? And the answer to that is that when you are referring to a method, if the method exists within the class, then you just put the method name. That's very important. But that only works if the method is actually in the class where you're making the method call. Okay, so now it's time for us to actually create our program that will use a coin. So we're going to go to the default package, and we're going to create a new class, which we'll call CoinRunner. We'll give that class a public static void main method. And then we'll say that this class will create and use a coin object. We will flip the coin repeatedly and count how many times heads appears. Okay, so now we are just about ready to begin as soon as we put our date on our project. Okay, so now I've got my coin runner. So what is my coin runner going to do? Well, as I've just described above, we're going to create and use a coin object. So how does one create a coin object? And the method is really no different than declaring any other variable. So let's start by actually reviewing how we would create a variable that we would use to count how many times heads occurs. When I'm creating a variable, I start by putting the variable's type. To create a variable that counts how many times heads appears, the logical type is an int, and then I need to give it a name. The name would be count heads, and then I give it an initial value. And since we're counting, we're going to start with 0. Now, those same steps apply to creating an object. What is our type in this case? Well, it's the class of the object that we're creating. So the type is coin. And then I have to give it a name. I'm going to call it myCoin. And then I'm going to assign it a value. Now here we use a Java keyword new, and then we're going to call a method. Now it looks like we're just giving the type again, but in fact, the parentheses here tell me that I'm calling a method. What method? Of course, it has to be the constructor method. Notice that the name is the same. So in fact, what I'm doing here is I'm specifying the type here, and I'm calling the constructor here. Okay, so now that I have a new coin, what can I do with my coin? Well, I can access any methods that are public that are attached to my coin. So for example, I can find out, well, what is the current face of my coin? So what I'm going to do is I'm going to print out the initial value of my coin is equal to, and then I'm going to use a method that is part of my coin. Now, if I had a string and I wanted to find out how long it is, I would type the name of the variable, hit period, and then access the method length. This process is the same for a coin. I'm going to type myCoin dot, and Eclipse even helpfully shows me my options for my methods here. And what I want to do is I want to get current face. Okay, so now I'm ready to actually run my very first program that uses a coin. I'm going to save my code and have it always save before I run it. Okay, now let's maximize that so that we could see it. So if we look at our results here, you can see that my initial value was tails. I realize that font is kind of small. Let's see if we can do something about that really quickly here. Appearance, fonts and labels. Java, appearance, debug, editor. Nope. Not sure where we change that, so we're going to pause the video for a moment and see if we can find it. And we're back with a larger console font. Hopefully that's easier to read. So as we can see, we have an initial value of tails. Now what I want to do is I want to flip my coin a number of times. And anytime we're going to repeat something a fixed number of times, we can use the simple expedient of a for loop. So I'm going to write for int I equals 0. We're going to start by just flipping the coin 10 times. And then each time we flip the coin, we flip it by calling the coin's randomize method. Randomize. That method causes the coin to be flipped. Of course, then I'm going to want to see what the coin's actual value is. So I'm going to once again output the value of the coin. But this time we're just going to print my coin dot get current face with no actual label. Okay, and then we're going to check to see if it was actually a heads. For that, we need an if statement. Now, how do we check to see if we have heads? Well, we could use get current face and compare it to string equals heads. But remember, as programmers, numbers are generally easier to work with. So let's use our coin and use another method to get the value of the coin. And what is the value of a heads? Well, we decided that heads was equal to 1. So if my coin is showing a 1, what am I going to do? I'm going to increment my count heads variable. And then after my loop is done, I'm going to output the number of heads. Okay, now my program should be ready to run. And I can see that my initial value is heads. Then I flipped the coin a number of times, and wow, that was an amazing run. I got 8 out of 10 heads. I'm going to expand the console here a little bit further if I can, so we can see the entire run, and we're going to run it again. That time I got 7 heads. Sure doesn't appear to be 50-50, does it? Well, now that time I only got 4. And each time I run it, I get a different random value. Okay, so as we've seen, we first took a coin, and the term for what we did here is we instantiated a coin object using the default constructor. Okay, then we called a public method for the object myCoin. We, of course, also called public methods here when we did getCurrentFace and getCurrentValue. That's it for a simple example of using a coin. I want to point out one detail here. Notice that every time we wanted to use a method from the coin, we had to say myCoin dot and then the method name, which is different than when we were actually writing the code for the class itself, where we didn't have to specify an object. And there's a reason for that. There's a special keyword in Java called this, and it's implied. We don't have to say it. But we could put it in front of all of the instance variables. Well, actually not there. We don't do it where we declare it. We do it down here. And that says that I want this object's randomize method. I want this object's isHeads variable. But we don't have to. It's implied within the class itself. Therefore, if I say randomize, I'm saying the randomize from this class, and since the randomize method is sitting right down here, it gets called.